Hello everybody, so I will be discussing objective questions on determinants, and this is of great use because in the examinations for class 12 you have a number of objective questions, 1 marks, 2 marks. So this section or this video helps you to understand this topic better. I am Suman Matthews. I am a math educator. I have been teaching mathematics for close to 3 decades, and we will start with a simple problem in determinants. So I will be writing and teaching. So given this determinant, I assume that all of you know the basic properties of determinants. So given this determinant, you have to find A32, capital A32. Now A32 is the third row, second column. Third row, second column is 5, and capital A32 is minus 1 raised to 3 plus 2 into the determinant obtained by deleting the third row and second column. Third row and second column, so I get 2, 5 and 6, 4. So this will give you the answer as 110. For those of you who do not know, A32 is given by the formula minus 1 raised to I plus j capital Mij, where Mij is the determinant obtained by deleting the ith row and the jth column. I hope this question is clear. We move to the next question. Solve this determinant equal to 0. So this is a simple determinant. So when you expand it, you get 2x plus 5 into 9 minus 2 into 5x plus 2 equal to 0. So your answer would be x equal to minus 13. Moving on to the next question. If x belongs to natural numbers, solve this determinant So again, when you simplify, you just expand the determinant. You get x plus 3 into 2x minus into minus. So you get 2 minuses is plus, 6x equal to 8. So I get 2x squared plus 6x minus 6x equal to 8. So 6x gets cancelled. I get 2x squared equal to 8, x squared equal to 4, or x equal to 2. Now technically x is plus or minus 2, but x is a natural number. So because of that you get x equal to 2. A commonly made mistake which students do is they ignore the fact that x is a natural number. So please remember that you have to look at the question and accordingly answer. Moving on to the next question. Is this matrix non-singular? Now when is a matrix non-singular? If the determinant of A equal to 0, then A is singular. Or if determinant A is not equal to 0, then A is non-singular. So I'll start by calculating determinant of A. So when you expand, you get 1 into minus 2 minus 5 minus minus plus 3 into 8 minus 6 plus 2 into 4 5 are 20 plus 3. So you get minus 7 plus 2 into 3 6 plus 23 into 2 46, which is not equal to 0. So because it is not singular, not equal to 0, you can say that the determinant or the matrix is non-singular. So always remember, if the determinant is not equal to 0, the matrix is non-singular. Okay, moving on to the next question. Find the adjoint of the matrix 2 minus 1 4 3. So I'll give you a tip to calculate the adjoint. Whenever you're given a 2 by 2 matrix and you have to calculate the adjoint, what you do is you interchange the primary diagonal. So I get 3 2 and change the sign for the other diagonal. So you get 1 minus 4. So always remember, to calculate the adjoint, interchange the primary diagonal. This is a primary diagonal, and change the sign for the other diagonal. We move on to the next question. Find K if this matrix 2K 3 5 is singular. As we had already talked about earlier, if a matrix is singular, then the determinant is 0. So I have 2K 3 5 is 0. So simplifying, I get 10 minus 3K is 0. So that means K is 10 by 3. So your answer is 10 by 3. Next we have, if A equal to 2 5 1 3, find A inverse. So I would start by giving you the formula of A inverse. A inverse is given by 1 by determinant of A into adjoint of A. ADJ stands for adjoint of A. Now determinant of A is 6 minus 5, which is 1, and adjoint of A, I have already told you how to calculate for a 2 by 2 matrix. So it will be 1 by 1, interchange the primary diagonal 3 2 and change the sign for the other diagonal, that is minus 5 minus 1. So this would be your inverse. Next we have, if determinant of A equal to minus 5, find determinant of adjoint of A. So we use this very important formula which is used a lot in your exams, competitive exams as well. Determinant of adjoint of A is determinant of A raised to n minus 1, where A is a square matrix of order n. Hence determinant of adjoint of A will be, here it is of order 3, and here you are given that just add the condition that A is a square matrix of order 3. So this would become determinant of A squared. That would be determinant of, that would be minus 5 squared, because determinant of A is minus 5, so your answer is 25. So a very useful formula, determinant of adjoint of A is determinant A raised to n minus 1. Moving on to the next question, n equal to 3, determinant of adjoint of A equal to 64, find determinant of A. So again we use the same property. In this case, determinant of adjoint of A will be determinant of A squared. So I have 64 because n is 3. 64 is determinant of A squared. So determinant of A is square root of 64, which is plus or minus 8. Note that we can have a negative sign also for a determinant. Next question. It would be my last question for today. A equal to 2175. Find determinant of A into adjoint of A. So here I make use of the fact that determinant of AB is determinant A into determinant B. So determinant of A into adjoint of A will be determinant of A into determinant of adjoint of A. Now what would be determinant of A? It would be 10 minus 7, which is 3. So this would be equal to 3. And now what would be adjoint of A? If you have to calculate adjoint of A, interchange the primary diagonal 5 2, change the sign for the other diagonal, minus 1 minus 7. So determinant of adjoint of A would be 10 minus 7, which is still 3. So substituting here, we get it as 3 into 3, which is 9. So determinant of adjoint of A is 9. So that comes to the end of this small video on objective questions on determinants. I hope this has been useful to you. So do subscribe to my channel or email me on matthews.suman@gmail.com for any more queries.